Okay, let's start. We have conic sections for this question. We won't focus on the geometry of conic sections. Each conic section has a proper geometrical interpretation that you should look into but we'll just focus on a simple diagnostic technique for figuring out which conic section is which. So we've been given a second order equation. Both of them have been given in the standard second order equation form in both the variable x and y. So we'll relate that to a test case. The generalized version of this sort of an equation is this equation where a, b, c, d, e and f are constants. This would always give you a conic. Which conic? That would be determined by this test. Let's call this the discriminant or the delta. It's going to be equal to b square minus 4ac. It's pretty similar to the quadratic equation b square minus 4ac, so it's easier to remember. Just always remember the sequence in which the first term is x squared, then xy, then y squared, then xy, and then constant. So just keep that in mind and you'll be good to go. So the discriminant is b square minus 4ac, b is the cross term, minus 4, and a is the x square term and c is the y square term, or the constant values with it. When the discriminant is less than 0, it's an ellipse or a circle. Now how to differentiate between ellipses and circles? That's pretty simple. The x square coefficient and the y square coefficient need to be same for a circle, and a circle never has a cross term, so that does it. If delta or the discriminant is 0, it's a parabola, and if it's greater than 0, it's a hyperbola. Let's do the test for both of them. The first thing you can see, x square and y square have different coefficients in both of them, so they're not circles. Let's look at the first one. What is the discriminant? It's b square, there's no cross term, so 0 square, minus 4 times what's with x square 1 and what's with y square plus 2, so it's minus 8. So del is less than 0. That means it's an ellipse. It's not a circle, of course, it's an ellipse. What about the second shape? Del equals 0 square minus 4 times 9 times 6, and again this is an ellipse because this is a negative number, and hence these both shapes are going to be ellipses. Now, of course it's important to figure out which shapes these are, as luckily both of them are ellipses. We'll just do one of them. Once we know the shape, we know what to do. The first thing you can do is always try and get it into the completing square form, which is almost always a better form to understand the geometric properties which are asked here. Okay, so we've analyzed it a bit so that we know what shape it is, and then we can talk about these very different terms that come in an ellipse. Now, the first thing I need to do is to complete the square. So I have these two terms. To complete this square, I need a plus 1. Keep this in mind because I'll add this on the other side. And then for the rest of the two terms, I have plus 2. I'll take 2 common. I'll say y square, and then this is minus 2y. I need to add another 1 over here to complete the square. So these are the two terms I've added. Rest of the equation is the same. So I need to add a 3 on the other side because you see 2 times 1 is 2 plus 1 is 3 to of course respect the equation. The first term becomes x minus 1 squared plus 2 times y minus 1 squared, and this becomes 2. And then you divide 2 on both sides as such, and this is what you get. Okay, so this is the standard form of writing an ellipse with 1 on the other side and completed squares in terms of x and y. So what is the center of the ellipse? The center of the ellipse is always given in the same fashion you would give the center of the circle. It's what is being subtracted from x and y. So 1 is being subtracted and 1 is being subtracted. Okay, like x minus h plus y minus k squared. Circles have this sort of a form. Ellipse also have this sort of form. The difference is that ellipses have an a square below and a b square below. Now these are the important sort of things that we have to make sure of. Now this is the standard form of an ellipse equation. Now we'll relate it to this equation that we have. So a square equals 2, hence a equals square root 2, and b squared equals 1, hence b equals 1. A gives you which axis? It would give you the semi-major axis. Why would it give you the semi-major axis? Because it's the bigger value. As it is coming below x, it would be the horizontal line. Okay, so the horizontal line would be given as y equals root 2 is going to be the semi-major axis, whereas x equals 1 is going to be the semi-minor axis. Okay. And this is semi-major axis. So we have some sort of a shape in mind. What we're trying to build is centered around 1, 1. This is the point. And the semi-major axis that we have is root 2 something. Root 2 is above it. Okay. And b equals 1 is going to go straight through it. So these are our semi-major and minor axis. Okay. It would be elongated onto the major axis. The major axis would have the longer sort of, it's oblong towards the major axis. Now, what are the vertices? The vertices along x from center are given as 1 plus minus under root 2 and 1. Why is this the case? Because you have to understand that whatever the major axis is, which is the x-axis in this case, would have the ellipse oblong along its direction. So you need to add and subtract from the center to get the those values. So there would be two vertices in the case of an ellipse, both equally distant from the center. What would be the focus? The focus is given as c equals a square minus b square. This is sort of the focal length. Under root 2 minus 1, 1. So focus is a displacement of the x-axis. So your two focuses would be 0, 1 and 2, 1. Which concludes this question, except for eccentricity. Now in the case of eccentricity, the definition of eccentricity for an ellipse is the focus, which is this, divided by a, which is this, whatever comes below x, okay, or the major axis. So you can just calculate that simply.